Hello again, and we're going to use derivatives to uh, on parametric curves to look at the following set of problems. So we're going to let C be defined by x of t is going to be t squared, y of t is going to be t cubed minus 4t. We're going to let t go from negative infinity to infinity, and if you we looked at how to graph this in a previous example. So in part A, we're going to compute dy dx. So remember dy dx is just, uh, you can sometimes write it y prime t over x prime t. Okay, so y prime of t is going to be 3t squared minus 4 divided by 2t. Okay, so we see that now we have our derivative. So there's our dy dx. Okay, so now in part B, we can show that C has two tangent lines at a point. Okay, show that C has two tangent lines at the point 4, 0. Okay, so the point 4, 0 should be more or less here. So there's 4, 0, should be right there. Okay, so if you remember, 4, 0 actually has two solutions here. So if we forgot, we can figure this out relatively quickly. So we know that 4, which is our x value, has to be equal to t squared. And if we solve this, that means t has to be plus or minus 2. And if we plug in plus or minus 2 into y, so y of minus 2 is 0, and y of 2 is also 0. Okay, so that means we have two t values that give us the same exact point, which then means we should have two tangent lines corresponding to those. Okay, so one thing to notice here, what's really going on is we're not plugging in the point, we're not plugging in the xy coordinate into the derivative, we're plugging in the t value into the derivative. So t is giving us the slope of the tangent line, not the xy coordinates directly. Okay, so let's compute dy dx when t is negative 2. Okay, so this should be 3t squared, so that's 3 times negative 2 squared minus 4, all over 2 times negative 2. Okay, so this should be 12 minus 4 is 8, over negative 4 should be negative 2. And if we compute dy dx when t is 2, that's going to be 3 times 2 minus 4 over 2 times 2 squared. So again, that's 12 minus 4 is 8, over 4 should be positive 2. Okay, so note that these are different slopes, so they have to be different lines, but they're through the same point. Okay, and sure enough, if we look back at our original graph, when t is negative 2, we're increasing. We're going from the bottom left up through the top right. So that would correspond to this blue tangent line. And then t increases, we go around this, and then we end up with this here as our tangent line. And so this is going to have positive slope, like this has positive slope too, and this blue one is going to have negative slope, which we saw here. So we can quickly verify that. Okay, so one other thing that we can do, part C, is we can find horizontal and vertical tangent lines. Okay, so horizontal tangent lines shouldn't be anything new. This is when the derivative is 0. So horizontal tangent lines are when dy dx is equal to 0. Okay, so our dy dx we found before was 3t squared minus 4 over 2t. So this is going to be equal to 0 when 3t squared minus 4 is 0. So 4 over 3 is going to be t squared, which means t is going to be plus or minus square root of 4/3. Okay, so something a little bit bigger than 1. Okay, and if we go back to our picture, we see we have 2 horizontal tangent lines. We have a horizontal tangent line here. We have a horizontal tangent line more or less there. Again, not drawn perfectly, but you get the idea. Okay, what about vertical tangent lines? We have vertical tangent lines when the denominator is 0. So this happens when dx dt is 0. Okay, so that means that 2t is 0 and t is 0. We're going to have an infinite slope because we're going to be dividing by 0 in our dy dx, which then means we have a vertical up and down tangent line. Okay, and when t equals 0, here we can figure out that it's not very hard to see that this is the point 0, 0 on our curve. If we look at our curve, the point 0, 0 here, if we draw the tangent line, it's all up and down. So we have a vertical tangent line. Thank you for watching, and we'll do another example.